Hello, hello, it's me, Patacotero, and welcome back to the streamer. Work. Yeah. Hold on a second. There we go. Eh. Okay, there we go. Welcome back to the Streamerino. So, as already discussed before, like as discussed last time, today the plan is to finish automating this guy here and automating coal power plant, the PPP. No, the PPP? No. The CPP. That's also not good. The coal power plant. Coal PP. Or whatever. No short names. No, I guess not. The coal power plant. So, and for that we need this little dude here, and that is the coal power plant. Coal power plant. Coal power plant. Coal power plant. And we've got to connect that here. Otherwise we cannot control it via the IC. The intention is that we can control that we're gonna add this functionality to the IC, to our combustion centrifuge IC. So today is a little bit of we're gonna write a little bit of assemblone. Hi, assemblone it is. Yes. Wait, that's in it. Here we jaws centrifuge. And then we're gonna jaw coal power machine. Oh, Reno. Coal powerinos. Vidodinos. Wambaladinos. Huh. Colorinos. Colorinos? Colorinos? Coladonda. So for that we need to get... Huh. Okay, hold on. I just realized something that's a little bit of a problem. For the coal power plant to function properly, we gotta... Yeah, what am I doing? I have to connect to this guy here, as that guy is connected up to the station battery. So we need to somehow connect that that connector with that connector, or have something that can transfer logic in between. So let's check out this here. So there are logic devices, and then there are various things. So there is a logic uplink. Oh, that looks cool. Oh, rocket data link. Huh. Logic select. Switch, lever, Logic transmitter. Rocket circuit housing. Communications. Logic mirror. That sounds appropriate. What does it control here? In. But we definitely have to go for that inside to build it anyway. But that sounds already like the thing that I want to do. Cancel pressurize. So now, electronics or printers. Logic. Kit Logic IO. Logic IO. You want a little bit copper? You sure about that? Got a little nickel. Ah, fuck. I need to go outside again and grab a little bit copper. 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 Koopa Booka Dookadoo. Chomp. So we need to grab copper. Did someone order 500 grams of copper? Okay. And in the copper goes. Logic mirror. I have to select a device for that. I guess batch reader is reagent reader. Batch slot reader. Logic batch. Logic mirror, slot reader, batch reader. Yeah, that thing. Okay, let's go with something like that. Now we have to connect up that stuff. But that can be done rather easily. Just like that. Next up is... we gotta select. The method is... yeah, average. The type is... upright wind turbine transformer batch reader. Hä? Oh. Yeah. Bummer. Fuck. Those are useless as an answer. God, I'm mess up all constantly right now. And I can't do anything here, damn it. So on the opposite side it is. Bam, bam, bam. Straight. Not so straight. Not so straight. Damn it! Wrong direction. Oh no, wait. Correct direction. Batch reader. From here to there. Good, okay. Phew. Nope. That was wrong. Wrong orientation. Correct orientation. Now then. Station battery. Method is average. Charge. Or ratio. I gotta quickly gonna go inside and check what the different values provide. What the battery provides as values, that is. So, charge is that. And then there is ratio. I think ratio is the percentage. And we care about the percentage. Ah! Come on. Station battery. Method is average. And we are at ratio. Why is it not green? Charge. So we load into our 0. Alias D charge D0, and then we can say D charge of the logic type, and then we got the logic type value setting. I'm unsure about that. Gotta check that. Oh, power comes from the top. That's why. Okay. So yeah, it is the wrong orientation. But oh well. Yep, the value of interest is called setting. So we read the setting and then we say S less than R1. R0 is less than what? Define min charge 0 to 2. Define max charge 0.8. So if it is lower than min charge branch greater than min charge 2. Store decharge no. Alias G generator D1. D generator on 1. And then we say branch less than R0 max charge max charge 2. Oh wait, BR, very important, relative jump. So if the charge is greater than min charge, then we jump relatively 2 at rest points. So we jump to here, skipping, turning it on. So only if it's below below min charge, it will turn on the generator. And here the same thing, but the opposite. Only if it's over the max charge, we turn the generator off. And then we jump back to RA. Confirm. Give me that guy. Export. And put it in. Damn it. Unknown at line 80. Oh. Yeah, okay. I get it. No. Charge. And generate the solid fuel. There we go. So once this goes below 0.2, the coal generator should turn on. Required power 5. And then required power 50. Which is a lot. Network analyzer. So yeah, that guy requires 50 watts. Just keeping it running requires 50 watts. Unbelievable. And that's like 10 watts. Okay, so then we already got that done now. We planned last time to automate the coal power production, and coal power production is now automated. Next up is further automation for the combustion centrifuge. I have one major problem with that. Let me demonstrate. The thing is, how shall we shut down the combustion centrifuge? How can we do that efficiently? Like, we cannot turn it off, that's the main problem. We cannot simply turn it off. The thing is, it has power, it has open, there is also lock, then there is on, combustion limiter and throttle. So, and there's open. So, the gray ones are the ones we can control. Lock is so that the player cannot control it. Okay. Then there is open, which is this lever here for ejecting, purging the centrifuge. On is turning it on and off, but that also includes the IC. And then there is combustion limiter and throttle. We could, like, use that to slowly decrease, try to slowly decrease the RPM using this mechanic. So yeah, because the problem is that ejecting stuff also produces stress. Like, if we throttle down, that produces stress. If we open up, that produces stress. It all produces stress. The only thing that that's easily and quickly lets us to stop the centrifuge without creating stress is turning it off. But for now, I wanna check out question: does stress reduce after time? Yes, it does, but it takes quite some time. The problem is, like, booting, we then have to wait for the stress to go down. Like, the stress goes up to when the stress reaches 100%, it will quickly halt. The RPM will drop to 0 rather quickly, but it will stay at stress 100. Then after a couple of seconds, it then slowly goes back to 0% stress. I will demonstrate that. So I'm gonna I wanna see how it will go. Stress goes up. Centrifuge slows down. We are still ejecting, essentially. But you can see the stress is at 100%. That's the screeching noise. And it takes forever to go down. So by now, if those would be producing and there's a little bit more buffer for iron, it would have been already purged, and we could boot it up again. We could start it up again. But as you can see, stress is still at 100%. Yeah, we now have to wait, as you can see, quite some time for it to finish up. It takes ages. Stationeers, combustion, centrifuge. Quickly slow down without turning off. Like, see, it's still... I don't know, oh, wait. Ah, okay. That was on me. Okay, that's something new I've learned. So having those all the way up is very unhelpful, as that will keep the stress up. We gotta try that out again, Turtle. We gotta experiment here. I'm gonna use the ISC to let it turn on again. So now all of them are burning again. Extreme power usage. How does it go? Not yet. Oh, okay. No, it's recently was powered up, so that worked. So now it tries to start up the centrifuge again. Okay, that was on me. So now we have to wait for the stress again to go down. Yeah, now we just now we have to wait for the build up to happen again. Okay, so there we go. It increased to 10. Now it's decreased again. It tries to slowly increase. But if the combustion centrifuge's stress is increasing too quickly, it reduces again. So like, that could be better. There we go. And now it's properly increasing the speed. As you can see. And once it reaches 30, it then increases, as you can see, the throttle. Works pretty well. The very first bunch of steps, it's took quite some time to get up on speed. So maybe we should change there the acceptance rate a little bit. But that level here so far, like on the upper few RPMs, I think the program is pretty fine as is. Now it just goes up. Okay. Let's try to continue writing the program. So this is speed up. That's when the speed is below 450. Let's change it to 500. As we know, it can be more than 500. The speed can be more than 500. So it will then go to speed up. But if that is not the case, then it will okay, then we're gonna read something into R0 from the centrifuge, and the question is what value? Combustion centrifuge. The combustion centrifuge has reagents. That's the value I'm interested in. Reagents. And if that is greater than, so if R0 is greater than some value we can specify, and I'm gonna do that, define, okay, like that's configuration mostly, so let's do that on top. Define max reagents to, for now we're gonna use 10. I'm gonna change that here a little bit. This editor is so fucking slow. Max reagents. Okay. BGT R0 less than if it's greater than max or well greater equal to BGE max reagents then do something. Okay. And what do you do when the max... I mean, go to that line. Where do you go to? You go to... how is it called? Purge. Purge. Purge, jump to RA. But this also changes now a little bit. We're gonna do that here, and we also load to R0 from the centrifuge open. BGE R0 max reagents purge. So if we are open, so like if we reach the max reagents, then go to purge. If the centrifuge is already open, then continue the purge. Like purge is opening up, and this it just says go to purge. What does purge do? Purge stores into the centrifuge for the value open. It stores a 1 in there. Or actually, it says BGE. It actually loads into R0 these reagents. Oh, and also... Okay, hold on. Gotta change the entire thing a little bit. Alias R reagents to R9. L, so we load our reagents from the centrifuge. Reagents, just like that, into our reagents. Let me say reagents. If we reached max reagents, then we purge, and if the centrifuge is open, we also purge. Otherwise, we check the RPM. So in here, we are already aware of the reagents. We now check if we branch wait, no. S greater than. So if A, which is our reagents, is greater than 0, then we store 1 in R0. Okay, like, yeah, if our reagents is greater than 0, we store 1 in R0. And then we store in the centrifuge the R0 as open value. What this effectively means in purge, open is constantly true as long as our reagents is greater than 0. Once it becomes 0, we set open to 0, aka false, closed, and in the next check, neither max reagents is reached nor the centrifuge is open, so we are at speed up. And to be honest, instead of, we don't need a check for that. We can just say, yo, please go to speed up, which is this here. Confirm. So we are at a high speed. We configured that the reagents are 10. So what that means is it should open. We have stress that slows down the entire process. Oh, okay, and I forgot one more thing. While we are in purge mode, I'm also gonna store centrifuge throttle 0. We gotta turn down the throttle. Very important. Okay, well, that was now the actual control mechanism. Or, hold on, something is... Wait. Centrifuge. It does various things, but it jumps to purge. If that is the case. Oh! What the fuck is that? Branch... NEZ. So if R0 is not 0... If R0 is not 0, jump to purge, aka openness on. So it has now shut down that. Is there... Okay. That would be really cool if we could print a state or some sort out into that tooltip so that we can just look at it and then determine what state it is in. That would be really cool if there's like a print statement or a debug or something like that. Debug, print. I mean, because there's not really much that we can change here. Would have been cool if there is like a way to debug it. IC10, debugging. Yeah, they always have apparently like a number, a console or whatever set up to do that. Okay, while that is running, I'm gonna go into base and eat and drink something, as I would otherwise die. And I need to restore get some air, and I need to recharge. Various things I need to do. So, first things first, let's eat. Question, does... There we go. Then we gotta drink something. Then we gotta refill... wait, let's recharge our stuff first, as the batteries would have to refill. Now let's get some new air. And let's get rid of the waste. That's a solid value.
Let me take you on a journey. Come with me on this journey.
2.5 megapascals.
In that base.
500 kilopascal.
Let me take you on
1.5 megapascal and 2.1 megapascal.
this journey.
Those are some solid numbers.
I hear home in that base.
Okay, guys. Let's go back outside. Okay, still got some dirty ore stuff. Yeah, it's still failing to boot up. I gotta reduce the sensitivity to the stress change rate, which is this number here. No, wait, hold on. That is this number here. No, wait. R0, yeah, R0 is the stress difference. And this here shall be 4. No, wait, that shall be 3, right? Confirm. Oh, come on. My main question for the centrifuge now is it faster to stop it and extract the resources, or not to stop and extract the resources while not overstressing it? It's like it's better to, like, I haven't like it. I don't think it's possible. Like, I don't think it's possible to keep it running while having it open. Like, the stress output is just way too extreme. Okay. I probably should here Mm. Max stress for increase. Max stress for min stress for decrease. Min stress change for increase. No wait, that's max stress change for increase. And that is min stress change for emergency decrease. And that is min stress change for decrease. Greater than. So if R0 is greater than, let's say, 4 in stress change, then it does that. So now it shall increase the throttle. Okay, that's not gonna work. Yeah. That didn't work.
Have you ever had a dream
I mean, do you guys maybe have another control idea on what we should do about on how we can control that thing?
Have you ever had a dreams that you had you would you can you do 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 you would you want you can do so you would do you would you can you do you would you can you do you would you can you do you would you want you can do so you do you can you want him to do so much you can do anything.
What would be a good control flow for speeding up the combustion centrifuge? Like, maybe we should use the combustion limiter. Maybe. I don't know. Hmm. So, now, increasing throttle again. And it's currently configured to off the 100 reagents to stop. I'm very unsure about that. Okay. I don't know. What max reagents shall we use? 1000? So guys, look at that. We should have now a fully automated deep ore mining facility. Gotta keep those two running, those two not, as I need nitrous oxide fuel for that. Super fuel instead of normal fuel that we currently have. So now that we have all of that facility, as requested last time, I wanted to ask, so what shall we do next? Turtle, please. Last time you decided that we're gonna do the deep ore mine, the deep miner facility. We now got the deep miner facility. So what shall we do next? I've sent a message on the Discord channel of all the various things that we could do. Okay, so let me repeat those options pretty quickly. So finishing, so the plan for next time, finishing automating combustion centrifuge. Don't purge when air is blinking. Instead, do it early since iron is backing up. Otherwise, and it can't be fully purged, or it has to wait for the arc furnace. Automate coal power plant. We did that, and planning the future. So planning the future is exactly what it says. Blah blah blah. So maybe we'll finish deep miner facility, which may or may not last long. The thing is about currently on a vending machine as storage, but as said many times, I want to use SDB silos instead. So maybe we're gonna start with the construction project of the central storage, which mostly consists of walking around and digging up a big room within the mountain. On the other hand, we could start working on rocket stuff, as we need to do that anyway for ice, most specifically volatiles. Then... Hold on. So, then... volatiles. Or maybe we could work on more power, but I think the coal generator is sufficient for now. Maybe working on getting air scrubbing and general airflow for the entire base working. That means running a long pipe to the opposite side of the base. That's essentially what that means. Or we could finally expand the atmospherics plant in one or both directions. Add the nitrous oxide, gas and fluid tanks, add cryogenic nitrogen tank on top, including trying to cryobed. Add a hot room below so we can control the base atmosphere heat finally more precisely. And maybe automating advanced furnace so we can specify target heat and target pressure and the stuff it does for us. Or we could work on getting more plant variety so our station is more happy. Or we could work on producing water, then use it for hydroponics, a shower and drinking fountain. Also do water purification if we do the shower. So, yeah. What shall we do, guys? Snake grows and wiggles. And saddens big and red. I love it. So,
what shall we do?
What shall we do with a drunken sailor? What shall we do with a drunken sailor? What shall we do with a drunken sailor early in the morning? What shall we do with a drunken sailor? What shall we do with a drunken sailor? What shall we do with a drunken sailor early in the morning? Council pressurize. What shall we do with a drunken sailor? What shall we do with a drunken sailor? Mainly between two, central storage or rocket stuff. Okay, so those are the things that Turtle has decided on. Central storage or rocket stuff. So then in regards of those two, I think I would go with rocket stuff because the mining facility essentially has somewhat of a central storage. I mean, the stackers and the vending machine and the sorters. Central storage is essentially exactly that again, but with SDB silos and on a multi-layer stage, so that we have one SDB, so like we have a sorting facility for ores that go into SDB silos. Then from the SDB silo goes into an arc furnace and then merges together with another sorting line and goes into another SDB silo. And that SDB silo then goes into a stacker, which is then essentially the output of the central sorting facility. Of the central storage. So, yeah. And since we have this sorting facility for now, so okay, that's what we recently built, a sorting facility. I don't want to have the next thing be a sorting, being as a sorting facility as well. And the previous bigger construction project was the atmospherics room, so and that one needs to maybe expand it. But I think I'm not going to do either of those two things, Turtle. I'm gonna go, but I will do the rocket stuff right after, because what I want to do first is something regarding atmospherics, and that is running a long pipe from here essentially all the way over to the base, to the opposite side of the base, and then have proper air circulation. Okay, there's null reference exceptions. I've heard that it's better if we reload the save, if you have that, if there are random null reference exceptions. So that's what we're gonna do quickly. But yeah, so, okay, plan is running one big pipe through the entire base for air circulation purposes. And after that, we're gonna continue with the next thing. We can use normal pipes here, as Terra is the best insulator. So we don't have to worry about problems in that regard. But like reaching the top is difficult. What the fuck? Because the other thing about this pipe here is that it may also help us in the future when we accidentally cool down the entire area again too much. Then this pipe may help us getting everything up to heat again. I want to make it make that pipe here a little bit visible, just as means of decoration, so we can see a little bit. There is technic stuff going on. Okay, so I'm gonna. The question now is how, from where I'm gonna run that stuff now, and I think I'm gonna run it from here. Here comes then the passive vent essentially, that will output the stuff of that pipe. I need another stack of pipe. The problem is that at this level there is the elevator. I have to destroy the elevator to be able to at least that's like only one package and doesn't have multiple build steps. Okay, now I need more pipes. I just quickly, by the way, decided upon doing the pipes now, simply because I remembered that we have a lot of pipes now to spare, and then we can work on that project here now. I had to do it at some point, essentially, and now we have some point in time where I was not sure on what project to work on. So I decided, like, now or never. Okay, I hope I can reach it. Ah, barely I can't. Barely I can't. Damn it. Fuck. Oh, thank goodness. Okie dokie. Okay, connected up. Perfect. So, now I need a passive vent. There we go. And then we need to connect up this pipe to the air scrubber. And I'm gonna connect it up to the elevator. Let's see if the pipes will reach. Oh. No. Oh no. One pipe. It's one fucking single pipe again. But I can get it by disassembling this guy here. By doing the following. First of all, we don't need this anymore. Only that. And next up, gotta connect that. Now we have a bunch of those. And Atmos Analyzer. Okay, that will take now a little bit to fully drain. Oh, damn it, look at that. Filters are low by now. Not the N2 ones, though. What about those? Huh. N2 are the lowest. But yeah, the filtration speed, why it's so low, is because the pressure of this side here is rather high compared to this pressure. So it would be good to to first of all have a turbo pump here to increase the pressure over there, as here it's just like we have a lot of a volume, but pressure is low, but compressing it down to a smaller area would increase the pressure. And then we also need a turbo pump here and a turbo pump there to decrease the pressure of the both outputs, output 1 and 2, to increase the filtration. Process input 4 moles. Right now it says like pressure differential 0 Pascal, even though like it technically is negative. But I guess like 4 moles is probably the minimum amount it will filter, I guess, and that's why it doesn't show minus. So yeah. But okay, now passive vent can go away, and we're gonna put this guy in there instead. And now we can turn this on. Oh, nitrogen. Don't need the computer, I need the tablet. But yeah, that pipe now gets pumped full of various things. And when we now go... Yeah, there you can see how that vent is blowing out all that stuff. And it's flying around here, flying down. And here it then essentially mixes and flows through here, over to here, and then into the vent. And now we have a proper scrubbing. Well, my goal is getting rid of the furnace, so gonna stop that, let them finish eating up that tank there, and then let wait until the pipe here is drained, so I can then destroy the furnaces. Then everything inside of the furnace got pumped out. So yeah, now we have proper airflow. And that is lovely that we now have proper airflow. Let's charge our stuff pretty quickly. Okay. Laptop also could be filled up fully. Hunger caution? Well then, let's eat something. The base is taking shape, right, Turtle? Right? We have now, like, resources. That is... for a long time, we didn't have to go mining. Deep miners were fully sufficient for that. We have a nicely heated up like base atmosphere with which we can breathe and stuff and walk around in without EVA suit. We got a nice filter setup and stuff to easily get the resources. We have like cable now en masse. We just had a lot of pipes en masse that are just consumed up, but can produce them again as we have a lot of iron after all now. I would say there's nothing to complain right now. Also, I mean, we are now always using the arc weld instead of the welding torch, so let's get rid of the welding torch and put the arc welder in here. Okay. So, now, I will try to get rid of the pipe and the passive vent as we don't need them anymore. So, filtration units are stopped now. What about the tablet? Okay, so we're still waiting here. Ah, okay, that probably won't change soon, as that's probably the stuff from the combustion centrifuge. Okay, then let's get rid of this guy here. Robot. Maybe the thing is, in the case of destruction of a furnace, for example, like it's smart enough that if I dismantle this pipe here, that it pushes the entire contents of that pipe into the neighboring pipes, which is really lovely. If I destroy it in the middle, it splits it up in both directions, which increases the pressure over here essentially more significantly. If I then destroy that pipe, all of that will be released into the atmosphere. But if I destroy this, then this, then this, it will be just simply pushed along, which is really lovely. Maybe the same thing happened now with the furnace, which would be lovely. Alright, I gotta store the furnace here as we right now mostly just use it for heating up spaces. Okay. The air is pretty good, I would say. Not even a mole. So, rocket stuff. It has been decided upon rocket stuff. The problem is I have no clue about rockets, so let's read the rocket guy. Rocket parts are printed on the rocket manufactory. Fuselage type A1 must be built upon a launch mount. A pumped gas engine must be placed in an engine mount type A1. Resource umbilicals are placed on the launch tower and connect between umbilical gas and umbilical socket gas placed inside the rocket. A computer modem with the rocket control motherboard provides a user interface to control the rocket. A pair of data links are used to create a planet-side logic uplink and a rocket-side logic rocket downlink, which must be hooked up to the computer modem. And rocket avionics should be placed in the rocket to act as the main rocket controller. On the rocket control motherboard map screen, you can set the rocket destination. Igniting the rocket without a destination set allows you to see rocket performance and fuel usage without launching the rocket. So like a wet test, or how that is called. Expect to how is that called? There are weird names for stuff like that. Expect to use 5 to 20 kilomole of fuel per rocket trip, depending on rocket size. A rocket scanner is used to chart unknown locations and discover mineable asteroids. More complex rockets may use rocket miner and cargo storage small. What is C5? But okay, so there are a few things that are must-have that we have to build, essentially, for the entire thing to work as intended. So, for now, I think the first thing that we need to do is a launch mount, as that is probably... yeah, that's where the rocket will sit upon, and then we need a launch tower. So, yeah. Rocket mount and launch tower. So, rocket mount. Launch mount. Okay. And that needs 60 steel. Ah, yeah. We have to make a bit of steel. I remember, we have to make a little bit of steel, as I don't have much steel left. Still running. Okay, so we need... for that to work, we need iron and we need coal. Okay, there is a iron ingot available. 500 grams. And then we need coal. So we have 500 grams of iron. How much coal do we need? So that is 500. Divided by 3. No, wait. 500? Yeah, 500 divided by 3. Well, how is that? Here, 500 divided by 3 parts gives us how much each part is, and this exact amount is then also needed in form of coal. But 500 divided by 3 is 166 period 6, which is... we can't produce that as coal. So that means we would need to have a we need to use a stacker to separate that. Or, well, another option is... grab the other bunch of iron. That's still not divisible by 3, but like 1... like we take like 500 plus 100 gives us 600. And 600 divided by 3 is 200. Which means we need 4 stacks of coal. Filter low? Why did it say that? But okay, so we definitely before we can go to the furnace, we need a stacker to split up the iron. It may be good to take a stacker with us to the furnace, as that might soon happen more often. Recycler, beacon, centrifuge. I need a stacker. Iron and copper. Ah! Got something in the eye. Ow. Gold and copper. Ah, here's a little bit of iron. I will be right back, just grabbing something new to drink. Okay, got a nice cold Almdudler again. Turtle, I got an Almdudler. Ah, that's the taste of the orbs. Very good. Totally forgot about that arc furnace. We could have put we could have taken that one and placed it over there. Too late to be sorry. Okay, so... Okay, so that is the furnace. That will take a little bit till everything, till all of that is molten. But now we are already, yeah. Because we melt so much, we have to provide the heat for the melting process. And that's why, yeah, now it doesn't do anything anymore because it doesn't have the heat anymore. We need to pump in a little bit more fuel for it to continue melting down that stuff. Like, it's the reason it cools down is not just because of the atmosphere around, but because it has to heat up something. It has to melt something. So now we have 600 grams of iron in there. And now we're gonna add a bunch of coal. And then we have to get the heat back up to, I think, 1200 Kelvin. And for us, so that we can then produce a little bit of steel. Well, a little bit is a little bit few to say. We're producing 800 grams of steel. Okay. So it's cooling down already. I would say let's pump out all of the excess stuff that we have now in there, as we don't need that anymore. There's pretty much nothing we can do with it. That has worked rather flawlessly, I'm surprised. Okay, so I'm pumping out all of that gas, like the ore, like the coal and stuff that produced some gas, and the exhaust gases from the previous steps, especially the pollutants, as that requires a lot of energy to be heated up unnecessarily. So that's why I'm pumping out all of the gas now, so that it can then pump in fresh new fuel, ignite that, and let all of that heat be used to mostly heat up what it itself essentially, and well, the already existing stuff in there. Okay. So now we gotta increase the fuel pressure. This time I'm gonna go with 200 kilopascal, and then I ignite it. As you can see, we are heated up and we can produce steel. As easy as that. Okay, and the rest I'm gonna pump back inside, as I don't need that heat anymore. I mean, I don't want to let all of that heat escape to the atmosphere, to the world. Instead, I wanna get all of that heat pumped into this pipe network here, as that gets then filtered down, and that way we can hold at least the CO2. The pollutants, they will be dumped into the atmosphere anyway, so there we lose some energy, but the CO2 is also very good in holding energy, if not even more than the pollutants, and we have more CO2, and I don't want, and we store that, so the energy it holds gets essentially held in our tanks, which then radiate and convect the heat away into our normal room. So yeah, we now have 800 grams of steel and additional 400 grams of iron. Amazing. So now I'm just waiting for it to all pump out everything of the advanced furnace again, so that it can then shut it down. As we don't need to keep it running constantly, but I want all of the gas outside. There we go. And now we can go back. Yeah, you can see how the temperature is here higher than over there. Okay, so now I can also continue to do that. Let me check upon the pressure of stuff over here to like nearly 3 megapascals. That is good. But let's continue scrubbing the air a little bit. Yep. Okay. So yeah, we got a shit ton of steel now. Okay, rocket manufactory. Oh god. Holy shit, that will take some time. Look at all of the air getting scrubbed. Okay, so We gotta wait ages for that. What else do we need? I mean, a lot of rocket stuff. Okay. We then also need a launch tower. Okay. Well, multiple launch towers, I guess. But we need a fuselage A1. And steel sheets. We need a bunch of steel sheets. Okay. Kit fuselage. 20 steel. Who would have thought? Oh, it gives us all of those. Okay, we need... Interesting. So I guess we need multiple fuselage. Wait, type A1. Type A1. A2. A4. C5. Okay. But it specifically says type A1. And then engine mount A1. Fuselage. There is no fuselage type A, but there is fuselage. Oh, here. Engine mount type A1. Okay. Whatever. Engine mount A1. Okay. I guess the other thing that we need is an engine. Pumped gas engine. Yep. And again, steel sheets. So we need a bunch of steel sheets. We could let this stuff produce some.
Hydration critical.
Oh, the pressure's rather high by now. 120 kilopascal. That's pretty high. Okay. So, launch mount. Got a launch mount now. Then we need fuselage. We need at least 3. Like a fairing, then one normal fuselage, and then an engine mount. Okay, pressure decreases over here. So that's like mostly just simple natural pressure differential because of this here. Yeah. I get that. That's why I turned it off now. I guess that is mostly the small little tank that we've placed in there that has a lot of capacity, like relative capacity, and it's like pumping out a lot of stuff that now has to equalize. Like there's a lot in that there's a lot of stuff in that tank that now needs to be filtered, and once that is complete, it then can continue with the next stuff. I'm gonna build in the meantime a bunch of filters. Gonna build heavy filter, steel inverstellite, steel. Oh wait, steel inverstellite, steel. Electrum. Inver. And stellite. One fuselage. I need more than one. Okay, that one is complete in regards of steel sheets. I mean, we need those. Okay. And we got that. Next step is nitrogen. Heavy filter nitrogen. That will take some time. I'm gonna make another nitrogen filter. Then we need CO2. We also make more than one carbon dioxide filter. And then we also need 2 heavy oxygen filters. We need those for the filtration plant. Okay, we got now 2 fuselage. I need 1 more fuselage. Okay, and now I need oxygen. Heavy. I mean, I'm gonna use heavy now because we have the necessary resources and they hold quite some time. Right now we are using normal filters, so yeah. I'm now just producing all of those filters that we need so I can until this 3rd fuselage is done. Gonna store that stuff over here pretty quickly. Put that there. Gotta keep the steel here. Okay, now we gotta stop that. Okay, and the oxygen filters are done as well. So now let me quickly put the fuselage away. Then we're gonna grab those filters. And let's go back to our facility. So, Pollutant. Okay. Those filters are still okay. But these are not.
Thanks for watching and have a good evening.
Yeah. Have a good evening. Okay. So I'm gonna swap those two filters pretty quickly because that it uses that one first, it seems. And then I'm gonna swap this out. So then we have this similar problematic here. Oxygen filter. No, a carbon dioxide filter. Heavy. Here nitrogen is still quite high. And volatiles only 1% left. Damn it. But okay. It's fine. It's fine. I thought we need more, especially over here. I thought they were way too small, but those filtration units still seem fine for now, it seems. Like here you can see we have like carbon dioxide 25%, pollutant 74%, 23% of nitrogen and 93% of volatiles. Like nitrogen is quite low and CO2 as well. But yeah, we got the filters now. I mean, we can then go simply in here and grab the filters as needed, I guess. One heavy filter for volatiles would be good, I would say. But other than that, it's okay. We now have the filters when we need them, aka a little bit of a backup. So one heavy volatile filter would be good. I don't think we need any else. I mean, we got the nitrogen, we got the oxygen, we got the carbon dioxide. We got the pollutants. Now we need the volatiles. Is there anything else that we might want? I don't think so. Volatiles. Heavy. Yeah. We should soon try to get a centrifuge up and running. Well, we do have a centrifuge already, combustion centrifuge. We could put the stuff in there, I guess. But yeah, and then combined with the recycler so that we can then recycle those here. They are all used, after all. Stop it. We don't need more. Okay. So far, so good. What else do we need? Pumped gas rocket engine. Pumped liquid engine. Ooh. But no, we're gonna go with gas engine. Gold and Copperino. Does that guy have Copperino? No. Does that guy? Yes, that guy does have the Copperino. What else do we need? We got the engine mount, we got the pump gas engine. We need an umbilical gas and an umbilical socket gas. Okay. So, yeah. Gotta wait for that, I guess. What else? I mean, okay, we then also need, like, the electronic stuff. Okay. Umbilical. Gas umbilical. So gas umbilical. Socket. Is it also gas umbilical? Yes, it's also just gas umbilical kit. So, means we need 2 of those, essentially. Then we need avionics, electrum, and solder. What else do we need? Umbilical gas is also gas. Yeah, okay. So then we need a computer modem, and we got one. Then we need a rocket control motherboard. And the electronics printer needs electrum and solder. Damn it. And we need rocket avionics. We got. I mean, we need a bunch of pipes and steel sheets. And we need logic uplink. Rocket downlink. Logic rocket downlink. Rocket data link. Uplink, downlink. Okay, so we need 2 of those. Rocket data link. I mean, there's probably also, like, we probably also need an umbilical power or whatever. I assume. Let's, just to make sure, make 2 of those. Power umbilical. Okay, that's a lot of stuff. I gotta put it into the... gotta put it all in here. Into the airlock. Since we need that stuff outside. At some point. I think that's, and I suspect that that's probably one of the best courses of action that you can do. Okie dokie. So, basic chutes, plastic sheets. Okay. Right. So now we also need that circuit board. And for that we need to eject what it contains. As I need those two things over here. Rocket control motherboard. Well then. Bong. Ah, fuck. I should have taken a few frames with me. Placement requires support frame below each pillar. Ah, okay. So like in the center one, that one has already frames, but all of the ones around it, they require frames placed by me. Oh, and I forgot to build some launch towers. Gonna grab that steel. Holy shit! Did I use the 100 grams, the 200 grams steel, or? No, wait, it was 300 grams. Okay, 300 grams. That seems like what I. That's what. Yeah, looking good. Launch tower. I need frame and sheet. Well, that one is producing one. I mean, we probably need more than one, so I'm let it produce at least two. Gotta drink something. And eat something. Oh, yeah, that one stacks. Nice. Finally, a thing that stacks. All of that all of that stuff here is unstackable. Okay. So here we have the trading platform, and Rocket will be a little bit further away. So here I want a little bit of pathway, here as well, and here can be maybe the rocket center here. I want a little bit of space. So yeah, this seems to be appropriate. So let's first finish do those frames here. And then... Oh wait, screwdriver? Okay! It wants a screwdriver to place the steel sheets. Now it wants the welding torch. And I also want the drill. Okay. There's that. Destination code. Interesting. Whatever that is. Requires frame or launch tower below. Okay. I will go with that for now. Must be constructed on top of fully constructed launch mount. Okay. So, engine mount. Fuselage type A1. And... fuselage type A1. Okay, and then... Ah, okay, so now I can place that guy. What umbilical? Gas umbilical. And then there's power umbilical. It's as if it doesn't matter where I place that thing. Oh wait, that's okay. That's the rocket thing. I don't know where to place stuff. Hmm. Okay. There's a on-off. Switch. Data link. And avionics panel. Looks appropriate. Umbilical gas. Umbilical socket gas. Umbilical gas. Wait. Umbilical angle. Oh wait, that's input. Hold on. Okay, I think... Nah. That is okay. Bam. And then umbilical gas. Cannot place outside of rocket. Placement that it connects to rocket needs to inside a fuselage or via umbilical. But I am inside a fuselage. That didn't work. Hmm. I don't know. Oh god damn it. Okay, that's the launch tower. Okay, it's already arranged as how I want it. There we go. And there we go. Huh. Oh, okay. I see. So that is not close enough, but that is. Okay, so here could be placed down pipes. Good to know. Now I can put an equivalent here. And they should be able to connect. If I understand correctly. They should be able to connect. And then we have here gas, and then I need a little bit more place, like, and then I also need a tank essentially, so that we can hold a little bit of that stuff. Damn it. Okay, they are now definitely on top of each other. Good. So if I want to think about that now, like that's, I'm using, yeah, I don't have umbilical power right now. Need that one. And then there are iron frames and iron sheets. Some more. Okay. That is okay. Okay, maybe not here, because here I have normal floor, of which which I can rely on, So maybe it's better to instead put these frames somewhere else. And that is over here, where I don't have the terra necessary. Okay, and now umbilical power also needs to be placed. And then connecting up like that. Good. So what's left is, I guess, a battery. I don't know if that guy here has a battery. And we need also a tank in which we can store a little bit of fuel. And then we need a little bit of pipe. Umbilical. Extend. Okay. Oh, thank goodness. Finally. Okay, we then also need an area power controller so that I can put down some power, so that I can get some power in here. And this thing needs to be connected up with the fuel line, and we need to use some insulated pipe for that. Is that the rocket engine? Okay. But that one needs pipes. Okay, so we need we need a rocket fuel tank, or however that is called. We need pipes. And we need an area power controller, a battery for the area power controller. And we need frames and iron sheets. And we need a computer, and we need, yeah, various things. Let's do that. And we also got a recharge. Swap the battery here. There we go. So let's put that stuff down. Yeah, pressure equalized again. You can see that now. 79 kilopascal. So we need iron sheet and iron frames. There were like special rocket fuel tanks or whatever. Fuel. Rocket gas fuel tank. I don't know how large those are. Ah, okay. Rocket gas fuel tank. Flashpoint. Cool. It doesn't tell. Oh wait, gas capsule tank small. Gas capsule tank medium. Requires 5 of those. Holy shit. Holds 60 kilopascals. At a volume of 1,500 liters. Okay. Tank small, requires 1 kit. 250 liters. I'm gonna go with 1 for now, and if we need more, we will see later. I would say. Okay, and I need insulated pipe. I don't think I have much insulated pipe left. Probably need to make new ones. I'm gonna walk pretty quickly over to the atmospheric space and check if and try to look for some insulated pipes. Is if we have one, nice. Not, gotta make one. Gotta make some. Okay, we got 14, which could be enough. But to be honest, let's just make more. Oh wait, we all okay, we also have that now, so we can put since we're already over here, we could put that away. But I also need normal pipe to build various things. Like the engine. Engine? Rocket engine tiny. Aww. Rock engine small can't be built anymore. Okay. Stirling engine. Pressure fed. Pumped gas engine. The most reliable of all rocket engines. The pumped gas engine runs on a 2-to-1 mix of volatiles and oxygen gas. Steel sheets, pipe. Okay. Needs 5 pipes. And we need a bunch of... Okay, and yeah, I'm definitely gonna make a few more insulated pipes. As we need insulin pipe. What does that have to do with insulin? We need a little bit of insulated pipe to, first of all, connect up the umbilical to it. And we use insulated pipe within the rocket, I think. I don't know. We will see. While that one is preparing, I'm gonna grab the stuff necessary for computer. But I guess that's already it. Don't need anything else. Power controller and battery? Yeah, right, power controller and battery. Thanks for mentioning it. Area power controller. Iron and copper. That one has a little bit of copper. And that guy has a little bit of iron. Okay, that's enough, because now I have exactly 2 stacks. Okie dokie. Power controller and very still large. Gold and copper, steel. Gold and steel it requires. Steel and gold. And then we maybe have all we need for rocketry. Can you imagine that? Wait, EVA suit. Oh, need to drink something. Well then, let's go outside.
Oxygen critical. Temperature critical.
Whoa! Ugh. I can place it there, what the fuck? No. There is placing on the floor is better. The fuck? Though I still don't know where I should put this here. Okay, I'm gonna put it down for now, but probably won't stay there. Need to do a little bit of planning, that's why. Data link. Because that thing also needs to be placed somewhere, and I kind of want to place it over here. Next to our... I mean, okay, that thing is so amazing, I kind of want to put it, like, all the way up there. But I need that to walk around over there, control that a little bit. So, yeah, but I kind of want to have it a little bit dedicated, because it's such a cool thing. It looks cool. Like, look at it. That looks cool. I want that on top of the mountain. You know, I want it all the way over there on the mountain. That would look amazing. But okay, for now, we gotta place it here. Only for now. Though, hold on. We need a place to put the computer down. So let me grab the computer. The computer. Computer goes down here. And that thing goes right next to it. And then we gotta do the power controller next to that. Okay. There we go. Gonna go indirectly via the other area power controller simply because I don't have enough cable. to do that otherwise. Ah, that one also needs connection over here. Okay. A little bit weird, to be honest, but okay. There we go, it's connected. And that stuff is powered. The lock, though the uplink doesn't do anything, it seems. But whatever. Cool. And that one here is complaining because no gas connection, probably. What does that guy require? Cable coil and screwdriver. Electronic parts. I thought it wants that, but I don't have it. And a motherboard goes in there. Open UI. Look at that fancy UI! Holy shit. Okay. Okay. Cool. So, next up, pipes. Okay, the rocket engine is done. Next up is a tank. Whoa. There we go. Should I connect it? I didn't think about that, but I probably should connect it. And then over here we probably should put down a cable connection. Okay, so the thing is, I'm mostly worried about battery right now. Like, we have a tank, we have all of that. Okay. That thing is also not connected up. That's what we should do next, I guess. Connecting up the rocket engine to the circuit stuff. But if we turn this off and this, or well, if we retract. Okay, it still has power. But do we know how much power? Nope. Is there like a rocket? Okay, there is a rocket battery. We probably should build one of those. And I think I messed up there a little bit. I assume, yeah. Like, right now, like, the gas socket was right above the power connection and network connection. So that's why I had to turn that around now. That was also not the smartest thing I've ever done. I could have put it over here or there, I guess. But it's fine. It's more symmetrical that way, to be honest. But yeah, more symmetrical that way. Eh. And I'm gonna do that so I can then put there the auxiliary rocket battery. That's the idea, at least. Okay. We need electronic parts for that thing, and we need an auxiliary rocket thingy, magic. All balanced. Is it closer to go over there for fuel or over there for fuel? Probably over there for fuel. And a wrench. We probably also need a pump here or something. So now we can turn that on and connect it. So that one is now filling with stuff. Total moles. No, that's a problem. That's a problem. That's too little moles. I mean, what did the guy say? The guide say that we need for moles per start 5 to 20 kilomoles. Okay, like this tank can hold at 1 megapascals at room temperature around 100 moles. So that's why everything is insulated, by the way. So yeah. Oh, that's a problem. It convects. That's a problem. It convects. I mean, can we just put a pipe heater in there? And then we need to... Then we would need to control the pipe heater. That's a problem. That's a problem. So we yeah, I gotta make sure the next time that I'm not doing that. Okay. We need an auxiliary rocket battery. Definitely. Would it not be fine to just fill when needed? Yeah, that's what I also think. Like, not filling it right now because now it cools down, but next time filling it up right before start because then we can launch it. And in space, I guess it's essentially insulated as it's in vacuum. And I guess the game simulates it as insulated. I don't think it will care about the sun stuff and make it gameplay wise a little bit easier to handle. But okay. Room temperature. So as we have figured out, room temperature 1 megapascal equals about 100 moles. That means we need to increase the pressure quite a bit to get it to get in the moles that we need. So yeah, for that we need a pump, of course, so that we can then pump in I think 60 megapascals or whatever the pipes can hold. So it means if we want like if we want to have 5 kilomoles, that means we need 5 megapascals. But it could go up to 50. So, yeah. But okay, so that is something we need. We need a turbo pump or a normal, like a turbo volume pump or a normal volume pump. But I think a turbo volume pump would be better as we want to fill it up as quickly as possible, essentially. And we need an auxiliary battery unit. And I don't think we need anything else, right? What does the rocket guy say? Rocket control motherboard, we got that. Computer modern, up and down link, umbilical gas. We even have umbilical power. It didn't tell that. Engine mount, launch mount, pumped gas engine. We don't have a rocket scanner, so we maybe want to add that. Rocket miner and cargo storage. Do we want to put in a rocket scanner? We could put in a rocket scanner. Let's put in a rocket scanner, but more importantly, auxiliary thingy. Auxiliary battery. Auxiliary rocket battery. Steel electrum solder.
Thank you guys so much. Have a great week and see you next time. Hey guys, my name's Luno and this Hey guys, my name's Luno.
Yeah, and that's the Cabrio car mix. So, what else? Nothing. Hunger! Hunger is next thing. Okay, electrum, solder, and steel. Gotta make a rocket battery. And scanner. Rocket scanner head. What is a rocket scanner head? Need gold and copper for that. Rocket scanner head. Doesn't tell me what it does. Rocket scanner. Doesn't tell me what it does. Ah, scanner head slot. Okay. I guess it's a consumable, essentially. That sounds like a consumable. Like you have to put a scanner down and then you put a scanner head on the scanner and that scanner head gets consumed over time. That seems to be what that thing is. That's a giant thing. Holy shit. That is rocket battery. Medium auxiliary. Yeah. Oh right, and we need a turbo. I want a turbo pump, not just a normal pump, but I need a turbo volume pump. Turbo. Gold, copper, electrum. All of that is in here. Rocket scanner. Gold, copper, electrum. Gold. And copper. And I need to drink something again. There we go. And now let's go outside. Turtle, we are so close on launching a rocket. Can you believe it? Ah, fuck, I forgot the electronic parts. Cycle to interior. Cancel pressurize. But yeah, here, 100%, that's a consumable. I can put the IC into the laptop for now and make one more slot available. Electronic parts. How many do we need? Rocket downlink. Rocket miner. We are not making a mining facility right now. Rocket celestial tracker. The celestial tracker can be placed in rockets and when turned on will provide data that can be used to orientate devices such as the telescope. The horizontal and vertical output is localized to the orientation of the tracker. You can calibrate your alignment by comparing the results of the primary body with the output from the daylight sensor. Full functionality will only be available in orbit, but you can configure using the primary body for aligning with the telescope. For aligning with the telescope, have the faceplate facing up and the cables facing in the same direction as for the telescope, and the output value will be aligned. What the fuck is telescope? Telescope can be orientated to observe celestial bodies. When within full alignment, will show orbital information for the celestial object. Atmospheric conditions may disrupt the ability to observe some objects at some time of day. To collect horizontal and vertical values, you can use a rocket celestial tracker while it is in orbit, or a daylight sensor for primary body data. Okay. So, do I understand it correctly? Like with that, like with a telescope and a rocket celestial tracker, we can track the rocket more, like better in orbit? Here there's no description. Wow. Pumped gas engine, mining drills, logic uplink. That's the thing that we want. But and wanna check out what we got else here just quickly. Data link. So those are the kits. Cargo storage, battery. So the rocket battery. Yeah. Okay. Rocket circuit housing. Okay. So I guess I want to build a telescope after we launch the first rocket though. So launching the first rocket, and then I'm gonna probably add this and a telescope, and then we can look into automated mining. Logic rocket downlink. We need an uplink. Cable coil, 2 electronic parts. Okay. Iron, gold, and copper. 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 Gold. Copper. But steel. Steel. I need iron. Iron. Okay. So 2 electronic parts. 1, 2. So let's see, guys, if we can launch a rocket successfully. Oh, and all furnaces are running, so that indicates that that thing here has worked, opening up automatically. Beautiful. Gonna check then if it really also goes full up. Would be interesting to know. Let's check what else we got now here, if there's anything new. Silicon! That is new. A lot of coal. Again, some iron. Okay. There's nothing else yet. Only iron and silicon. What about copper? How much copper do we have? Okay, copper is close, it seems. Gold, there's also silver, yeah. Okay. Not too shabby, I would say. Not too shabby. Though, maybe turning on a third one would help. Unsure about the production rate, to be honest. Maybe our centrifuge is fast enough for 2 of those. I mean, there is no dirty ore anymore in here, and previously there was. If it would be equal, then there should still be some waiting, but no. So I guess let's turn on a third deep miner. Like, I mostly was worried that our centrifuge is too slow, but that is okay. I mean, that it can't handle 4 is probably okay. I'm unsure, but I thought that for it to handle 4 deep miners, it requires nitrous oxide fuel. I thought so, at least. So it now is trying to increase speed again. And it's definitely a lot bolder in regards of getting the speed up quickly, it seems. But we lose too much RPM. It should have already turned, like, it would have been good if it had increased the throttle, but it didn't, and now it's back at 50 RPM again because it took such a long time to get the stress down. Damn it. It decreased the stress again. The throttle, because the stress too quickly turned up. It's too scared. That's a big problem. And just 70. Did I configure 80%? Okay, now it can. Throttle is still at 10 and the stress is decreasing. That means it's now can go into full speed. So now we need those. And uplink done. Oh, and now we can logic rocket downlink. There's only one. Bam. Open UI. And rocket. Ooh, lots of rocket stats. We're gonna look into those later, not now. We're not done with our rocket after all. So, turbo pump goes to there.
Look into my eyes. What do you see? What do you see? So I dip my toes in the water and it takes me farther out. I see.
Oh, you can select directions.
So I dip
Cool.
my toes in the water and
Didn't know that.
take me
Wait, that's the rocket scanner. There's a in and out? What the fuck? Is it not fully built? Does it need more stuff to be built? Welding torch and steel sheets. Really? Are you serious? I can't go out! Can't leave the rocket! Oh, okay. Over here is the cable connection point. So a big question is, can we control? Like, okay, so now we have a lot of stuff. Let's learn about this UI. Okay, devices. We can turn auxiliary rocket battery. Gas capsule tank small. Pumped gas engine. Rocket avionics. Rocket scanner. Okay, we can write those. Cool. but is at empty. That is not good. It should charge. Why is it not charging? Is it not allowed to base upon itself? I mean, that's certainly possible. Let's try that out. Damn it. It's one of those. I need a lot of heavy cable for that then. I need a heavy cable here, I need a heavy cable over there, I need heavy cable everywhere. How frustrating. Can I put that thing one step further up? Okay, nope. That level is the only one that is allowed. So if I want to use that tank, okay. I lost a lot of fuel to that. I think. Oh god. So we gotta do... You have to do something about that. So a heavy cable down, and then battery. In this orientation. So here we have now the on-off button, and here is the control, like the connection, so that we can read upon it when the rocket is not here. And we have to connect. Here we can use normal cable, as it's all about what gets consumed in the end, and the stuff that we have here probably doesn't consume as much as it would then cause everything to explode. So I hope at least that this here will be okay, just fine. I hope. And then I also want to connect up this guy here. So that we can read the tank level. The fuel level. So everything is now connected up again. I hope. Scanner is also placed. So yeah. tank and stuff is also ready. So, yeah, I guess that seems like a proper solution to what we try to achieve. The main problem right now is, though, we need a heavy cable to this. We don't need a heavy cable to that. We can leave that here as control and stuff, but we need to connect heavy cable to that port. Well, or a transformator. Yes! Let's do a transformator. That could work. I do have a small transformer. I do have a small transformer. Let's grab that one. Then we don't need that much heavy cable. Yeah, transformer small. And eating and drinking. Ah, that one needs surface. I guess it doesn't matter where we're gonna place it. Okay, I don't think a transformator will let that stuff through, so... Power critical, you say? I don't believe ya. How much does cable hold? Normal cable, that is. 5 kilowatts. What at 5 watts? So, this should not cause any further issues. Battery should now get charged as intended. But that stuff consumes now so much power that I can't use my computer. Ratio 0.24. Okay. That one needs quite some time to charge. So maybe getting heavy cable is still better. Then it will charge faster after all. You still there, Turtle? Or did you already leave? No, you're still here. Okay. Not that you go right before we test the rocket. I mean, we are now to like what's left now for the first rocket test, if I understand correctly at least, is turbo pumping in the fuel that we need and charging it. That's all that is left. We're currently charging right now. Anything else we can't do right now, as it's charging consumes all the power, so gotta wait. And I'm trying to make it more useful by trying to get a bunch of heavy cable, which would allow faster charging. Like that's the goal of creating heavy cable right now. Allowing faster charging. And when that is done, we can, and when the rocket is charged, then we can try to make a test run. Only a test run for now. It's not the final thing. It's really just a test run for now. I don't know if that is enough. We will see. Like those rockets here, I haven't never used those rockets. I used the modular rockets before, but these rockets, where you can like build stuff inside and have to build pipe networks inside and stuff, that is also new to me. Okay, so it's now charged in the end, so okay. Next up is fueling it up. Okay. Ratio is 1. Auto land is enabled. Landing altitude 25 kilometers. Confidence very high. At least 8.11 kilonewtons engine thrust required. Auto shut off. Abandon. Okay, so that is the map. We could fly to that question mark, we could fly to that question mark, or to that question mark. Let's set that as destination. Current action, none. Launch mount, okay. Rocket. Has run out of fuel. Has depleted its batteries. Oh, come on. Really? I have to fill up my gas tank. Otherwise, we cannot have a look at that stuff. I mean, we probably don't want to die while we are checking out the rocket stuff. Let's also change the battery and drink. Okay, Turtle, let's launch a rocket. Let's launch a rocket. But for that we have to understand the UI first, so. I mean, the guide was not really helpful on that. I mean, we're gonna check it out again, but oh, come on. I need stairs or whatever. Hold on. Okay, so now we can essentially walk to there properly. Using that, we can walk over here, and then we can walk all the way over here. No need for jumping or anything. Okay. So we care now about various things. Gas capsule tank small, and oh, we can favorize stuff. I do care about those. Why is there a setting? What does that setting do? But okay. Oh, and total moles are also interesting for us. Rocket battery ratio. That is in kilopascals. That went up pretty quickly. Rocket fuel. Rocket fuel tank. Gas capsule tank small. 60 megapascal. Okay. I intend to put 30 megapascal in there. There we go. Yeah, there's also some other stuff interesting, and that is ratio volatiles and ratio oxygen, and after that nitrous oxide as well, I guess. Temperature is decreasing, okay. But this here stays the same, and total moles is also the same. Okay. Total moles is now is about 3,000 now. Like, and the guide said what about the rockets? Rockets. Between what, 5? Oh god. Depending on rocket size. 5? Are you kidding me? That means I need to put in 50 megapascal. Like, my calculation is off by a factor of 10. Like my previous calculation, I need another tank. Yeah, it's only 3 kilomole. No, wait. Yeah, it's only 3 kilomoles. A calculation is off by a factor of... Oh, by a factor of 10. That's not good. I suspect that that this will end as Kerbal Space Program. There we go. Pressure is now slowly decreasing, but total moles is now a little bit more than 50. Temperature decreases due to... pressure is decreasing due to the decrease in temperature. Just pumping in a little bit more. Okay. That's okay for now. I don't know what that is. Auto shut off. It's like for flying or whatever. So that is the weight. Oxidizer. Battery 99%. Altitude. Gravity. Fuel time. Next location. Launch mount. Okay. Current location, launch mount, target location, none. Map. Set destination. Okay. On the rocket control screen, you can set the rocket destination. That's what we did. Rocket avionics should be placed in the rocket to act as the main rocket controller. We did that. Igniting the rocket without a destination set allows you to see the rocket performance and fuel usage without launching the rocket. Expect to use 5 to 20,000 moles of fuel per rocket trip, depending on rocket size. Rocket scanner is used to chart unknown locations and discover mineable asteroids. More complex rockets may use rocket miner and cargo storage small. Okay. I mean, target location is none. Okay. I just wanted to press that button. They wanted me to test it. I don't know. How does that work? What do I have to do? Do I have to turn it on myself, or... But it said, like, if no destination is set, then nothing will happen. But, like, how do I set orbit? Oh, wait. Europa orbit. There we go. I have to select... Okay. Set destination. Ah, okay. Europa... acceleration... Fuel time. Target location Europa orbit ETA. Next location ETA. The question is, how do you control it? Okay, let's save as Europa, save world, override, and additionally save Europa. Okay, wait, hold on. Save as Europa pre-launch. As you can see, Mars pre-launch, that was with the modular rocket. Let's save as pre-launch. And then we're gonna go back. No, not the settings. And then we save as Europa. Save world. Override. Okay, guys. We've set the Europa orbit as target. Let's see what happens if we start the pumped engine. There it goes. Target velocity, 400 meters per second. Okay. Oh, it automatically shut off. That's... Ah, okay. Whew. Has arrived at Europa orbit. We are in orbit, guys. Like the previous... Like the modular rocket was like... the modular rocket constantly consumed a little bit of power. Constantly consumed a little bit of fuel, essentially. And then you had to ensure that your rocket comes back. So that, like, you had then to tell the rocket to come back with a little bit of fuel left. Otherwise, it would crash or get lost in space. I mean, here it can also get lost in space, of course. But we have... Oh, shit. No, wait. 5 kilomoles. We stored a little bit more than that. So, okay. But yeah, so... It doesn't consume, which is good. Temperature is still sadly dropping. I don't know why or what to do about that. What to do, how to fix that. I have no clue. Battery is at 98%. That is very good. Here we can see the moles as a whole. Okay. We are in space now. And all of that stuff is looking good. Look at that guy spin. The pressure of the pipe is dangerously high. Okay, I think it's now happy again. Okay, so, map. We could now try out the rocket scanner.
Power low.
Rocket scanner. Oh. Charting. Total chart points generated at this location. Okay. Nav points charted at this location. Okay. Total points required to fully chart this location. Okay. So we can now just simply essentially invest a little bit of invest power and scan ahead into charting. Okay, and when now after this charting, we then will unlock those 3 celestial objects, and they should appear in the map. There we go. Io. Ah, okay, 200 and then 450. 100 delta V. So, like, keep an eye on energy. Yeah, I'm keeping an eye on energy. We are at 95%, so that is easy going. So if you guys remember KSP and stuff, like, if you want to travel in space, all you care, like, you usually care about... You usually care about delta, like, the stuff you care about is delta V. That's what you essentially that's what you're required to go from one place to another. And this stuff, and you usually can rather easily translate fuel time with delta V. Very important, fuel time and not fuel. That's depending on the engine essentially. And how much delta V, that's also dependent on your rocket weight. Just saying. Very important. So now I'm just waiting here a little bit for the charting to happen. Energy 92%. That is looking good. Waiting for some charting. We want to chart everything. I mean, come on, it's the orbit. It's our own orbit, so I want to chart everything. Soon we are done. And we are done! Hooray! Hold on, guys. Okay. What does rocket energy say? 89%. No further nav points to chart. Okay. So we are back at idling, so there's that. Rocket scanner can be turned off, so it doesn't consume power. Wait, how much power does it consume? 200, okay. What else do we have? Map. So there are a bunch of things now. So there's Io, then there is Ganymede orbit, and then there is prograde moon transfer. And then there are other celestial bodies here available and some here available. But to check them out, we have to go there. Okay. So we have a little bit of fuel. So there is Io orbit. Location info. Okay, that is that. Location info. So we need 100 delta V to get there. We used like 400 to go up. And we consumed 1000. So I would say let's go to Io. Just because we can. Let's fly there. Io orbit. And let's go. Oh, okay. Target velocity is 201 meters per second. Okay, something is wrong about the delta V setting. That's not good. Okay, but now we are at Io. And now that we are at Io, we could chart. Okay, we need to activate the rocket scanner for that. And now it's charting Io. Site discovered at this location, nothing. Total discovered points generated at this point, nothing. And total server points generated at this location, nothing. Okay. Do I need to mount a telescope on top of a rocket for that? Or how does that work? So here it's just 200. I'm gonna go to base pretty quickly to recharge and drink. But I'm confused now. About what? Well, like the other stuff that's there, like it's like the rocket scanner said, like I have to have that on board to be able to check out asteroids that we can mine and stuff. So I'm a little bit confused about that, on how that works. How can we mine asteroids? I mean, I cannot. I don't have the equipment on the rocket, but what do I need to do that, essentially? Ah! Tidal fragments. Location info. Copper fragments, gold fragments, and silicon fragments. Size. Size increase the base yield and decrease the degradation rate of the density and richness. Degradation rate of density. Size increases the base yield and decreases the degradation rate of density and richness. So like the longer I mine those, the more goes the density down, or what? Density affects the total resources available and mining speed. Richness provides a short-term boost to the yield. Or how does that work? That is has not been described yet. Location info of IO. No site discovery and no resource, like tidal fragments and IO condensates. Okay, so we have finished scanning that. So we have 4,000 left. I mean, we could still like. I mean, we could continue further. 1,494 moles and 3,000 moles. I think that we could continue further. Location info. Sites discovered at this location. This location has 9 sites. And discover points generated. Nav points. And total survey points. And this thing has that stuff as well. Okay. What about location info resources? 2 till 4. Like that one looks better for that. It has nitrogen, pollutant, nitrous oxide, and volatiles and pollutant. Like that one is interesting for gas stuff. $120 meters per second. Let's go. Rocket has arrived at IO condensate. And discover. Oh, that's a new process. So charting is finding new nav points, and discover is then this stuff here, I guess, and this stuff. The question is, what is the like? There are now like, what is survey and what is deploy? Like mine is kind of obvious. Like that is, let's mine that shit. But what is deploy and what is survey? is resources only available when we have mine, but still. And maybe that guy doesn't have any other nav points, and that's why we can't do chart. I guess. Battery is still looking good. Okay, so like scanner strength is what? Is probably what it gets, what it adds to the discover progress when it's done with the scan cycle time. And that is probably in seconds how long it takes to reach 100. And then add essentially scanner strength. Yeah, 30. Okay, we got one. This sites discovered at this location. Ah, okay, so those are sites. Pollutant condensate and volatile condensates. Okay, those are sites. Ah, and then I have to fly there as well. Okay. Location info. Aha. Okay. Okay. I see. You then have to go there. And then you can do a survey there. That's wild. Like more and more steps. Okay. What do you have to look out for? The fuck? That's crazy. Crazy. So that is discover. And then when we fly to such a site, like this pollutant condensate, we can then survey. And survey is then probably figuring out what resources there are. Survey targets here. Composition size, density, richness, mining boost, and mining boost. So now we have 3 locations. What's the difference? Location info 10, 30, 60, 100. 10, 30, 60, 100. 10, 30, 60, 100. Checking if that changes. Location info 10, 30, 60, 100. Okay, no, it doesn't. I guess it then depends on what the survey gives us. So we then would have to decide upon one and then survey there. But like we were able to decide between those two, as that one showed us. Okay, it's you can only expect rocks essentially, and here you can only expect ice essentially. But it doesn't tell me what I can expect of those sites. Rocket power looking good. I think I'm gonna leave that one for now and then check out one site, because then I want to do I want to survey that. I mean, now we have 4 sites essentially. Okay. Location info 10, 30, 60, 100. Also doesn't show me anything. Okay. But the icon is a little bit different. That's why I was a little bit, But okay. So now I want to go to there, set destination. Go back to the rocket. Rocket scanner turned off and pumped gas engine. Target velocity again 200. But okay. Oh, it's animated. Slowly flying there. Okay. So now we are there. Location info. And now we can survey. Rocket scanner. Okay, now we have to survey 100, I guess. And then we will see what resources we have. Oh, no, we can directly see that. Ah, okay, so now depending on how much we survey, we then unlock these survey targets. So that means we can, by simply investing more time and power, we can then get a mining boost.
Power low.
Okay. But what is deploy? And done. Nitrogen 4 moles, pollutant 19 moles, and nitrous oxide 1 mole. So this gives us essentially nitrogen ice, but with a lot of pollutant that we would have to heat up. Let me note that. And now the question is, what does these mean? What does density mean, richness mean, and size mean, and how do they relate to each other? Maybe something mining, smelting. Nope. I mean mining drill. Okay, and mining belt, yeah. But okay, so it doesn't tell me about that, sadly. Wait, why does it show me this stuff here? Can I use a normal tank as well? What's the difference between a normal tank and a rocket tank then? The last one you discovered was a volatile site. Aha, okay, I see. So this small little icon shows what type of gas I can see, or is there a reading for that? Oh, there, volatile condensate, pollutant condensate. Ah, okay. Thanks. Okay, I see. Very interesting pollutants. Yum yum. What if I set that as destination? What is the delta V? 200! No, not gonna do that. Clear destination. But okay, still. Now, the question now is, what is the relationship between density, richness, and size? I mean, similar settings we got here, like size, density, and richness. Like, that's the stuff that we can discover here. Like, we can expect, like, the things we can discover is pollutant and volatile condensate. And though, okay, those are sites that we could discover. Those two. And then there is like, those are the ranges essentially. So, okay, but like size here probably means, yeah, okay, no, because it says 9 sites. That doesn't add up. So yeah, what? I guess then each thing that it can discover ranges between its resource settings, then range between those. And then we have to check up on the sites themselves to figure out what exactly those values are. So that we can then see density, richness, and size. But, okay, first of all, why is the order different now? Like, now it's the density, richness, size. But over here, it's size, density, richness. Ah! But okay, that is nitpicking, I know. But still, what is the relationship between those? I mean, there was a description. Like here, size increases, blah, blah, blah. Hold on. If we go there, location info. Ah, okay, wait, here. Tooltip. Density affects the total resources available and mining speed. Estimated total resources 10,000. Mine speed 8.7 seconds. Does mine speed mean that I get all of those resources within 8.7 seconds, or does it mean one resource within 8.7 seconds? Richness. Richness provides a short-term boost to the yield. Richness is increasing yield by 418%. From 10 to 42. No, one per time. Okay. Riches is increasing yield by 480%. From 10 to 42. So, okay, wait. Okay, hold on. If I understand it correctly, this means there are 10,000 resource units essentially available. One resource unit by default gives us 10. I guess at least that's expected can be more like 10. So another question is now, like, if I say mine speed is 8.7 seconds, does it mine within 8.7 seconds without, like, let's ignore the richness. Let's assume the richness is like 1 or whatever, so like 10. Would it then within those 8.7 seconds mine 10, which decreases the total resources from 10,000 to 9,990 and not 99? Like, does it decrease the total resources by 10, or does it decrease the total resources by 1? Okay, is it multiplied or not? Or does this because then the question is, if we have now the percentage here, does that mean that it just increases the mining speed essentially? Because that would then mean that within 8.7 seconds, we mine 42 resources, which will leave the total resources 10,000 minus 42. Or is it 10,000 minus 1? Which means that we have 10,000 times 42. Size increases the base yield and decreases the degradation rate of density and richness. Size increases the base yield and decreases the degradation rate of density and richness. Base yield 10. Density degradation 0.03. And richness degradation 0.033. So those two go down over time. I guess we will see once I mine. Rocket has no mining device, yeah. I guess we will see if it mines, if it's like 10,000 minus 42 or if it's 10,000 minus 1. I guess. We will see at some point. But okay. We are not done with our rocket exploration here on how stuff works. So there are like, right now, for me, there are two things left to consider. First, what is deploy? Okay, what is deploy? And secondly, the mining. I want to try the mining so that we can get to understand this stuff here more. But for now, let's fly back home. Set destination. Europa orbit. Target velocity 200 meters per second. That's interesting, to be honest. That's very interesting. What the fuck? Huh? Can you, like, really? What the fuck? From here to there, it was 200 meters per second. But from here to there, it's also 200 meters per second. We don't... What? Oh, wait. No, okay. Next location here. Okay, it plans a route essentially, and that's like for the next step. I see. But okay, we're gonna fly home now. We gotta burn it for 25 seconds. And the fuel time was 100, so that is good. Okay. And now we fly back home. So we flee from here to there, and now we're flying home. And we are back home in orbit. And now we want to launch mount. Right? Europa orbit. And we now want to land. There's confidence. So... confidence is very high. Okay. Deploy could be for satellite tools or some rover-like thing, I guess. Yeah, that would be amazing. What the fuck, rover and shit? We will see. But satellites, what about the satellites? What do they do? I mean, okay, maybe a relay station so that the uplink thing works. Okay, I get that. But rover? But like, if that is the only point of satellite, oh come on! I would expect more of stationeers. So we will see. I mean, look at in the background. You can see there is like a door to get inside, and there is like a cargo storage, like a lock. We can open that. We will see. But where is those nice cable? Like, where's that coming from? I haven't seen that. I want to get that as well, like these amazing cables. That's lying to me. Yeah, I know that don't know if they exist. I don't know if they exist, but that would be cool. If, like, the most amazing thing is, it would be cool if you have to build robots, put them on the rockets, fly them to somewhere else, and then deploy those robots, and then you can remotely control those robots. That would be cool. Kinda like in Factorio Space Age. But okay. Rocket scanner. Pumped gas engine, rocket scanner. We want to fly. We want to land now, okay? So, set destination. We want to land. 400 meters per second difference. The confidence is very high of landing. I guess the confidence here is a relation between rocket weight and engine power. I assume, because at least 800, at least 8.11 kilonewtons of engine thrust required. And if we check the pumped rocket engine, pumped rocket gas engine, exhaust velocity, like here, max thrust is 16.2 kilonewton. So yeah, I guess that's okay. So launch mount, next location, launch mount, and the thing is, like, auto land is enabled. Confidence very high. I don't know what happens if you don't do that, to be honest, but okay, let's go.
Hydration critical.
Impact velocity. It's like, I think it's probably waiting for, like, it's doing probably some air brake stuff, I guess. Because it doesn't increase or decrease right now. The engine is probably shut down. Okay, no, here. Throttle is down a little bit. And we don't use much moles right now. Hold up, did it destroy your charge port? Yes, it did! And the gas thing as well. But why did it do that? I mean, what the fuck? Oh! Yeah! Because I'm stupid. I know why that happened. Because I forgot to disconnect it. Like, you had to, like, there was this button to connect them up, but I forgot to press it to disconnect it. Next location ETA is -1 second. Did you disconnect them? No, I didn't. And that's probably why it broke. Stupid Panna. Okay, but like, we have to wait a lot of time. Like here, I don't know why it switched so drastically, but like over 300 seconds to till the rocket arrives. Landing takes apparently quite a long time. I'm now very hungry.
Hunger caution.
I'm on it. Don't you worry. We really need to get bake some new stuff, but I don't want to miss the rocket landing. Priorities. I mean, okay, let's just bake those potatoes. It takes such a long time. Absolutely amazing though. But still, question is, what does deploy do? I gotta Google that. And turn it on. Baking! That wasn't planned through. Ah, fuck. Come on. There we go. Now let's head outside again. I'm gonna also check on stationeers, rocket deploy. Deploy button. Rocket manufacturing, blah blah blah. Yeah. But what does it do? Recipes, versions, tiers. Tier 1. Okay. The auto landing that you are currently using can be replaced with a program that is more efficient. Aha. Oh, that's probably then the rockets that I've seen always crashing down. Because like when you search for stuff in that regards on Stationeers Wiki, oh look at the rocket! Then you can see it like BAM! How it rushes down. It kind of looks alien, to be honest, like because of the blue light. It kind of looks alien. Another thing that I just realized that I forgot to do is complete the fuselage. It's not completely built. Okay. That's good. That's funny. But okay. Rocket is back. You basically sent an experimental rocket. Yeah, probably. But okay, that is cool. So that works. Cool. How much fuel do we have left? Okay, we don't have much fuel left. So pretty good. 900 moles. Oh, not even. Hold on. I can't do math. No, wait. 8 plus 3? Oh, I guess probably... No, wait. Huh? What? I don't know how that number comes together. That's weird. But okay. Whatever. That was exciting. Interesting. Worked. But okay, so... And you say that I could replace that with a program that is more efficient. I see. I mean, yeah, the entire thing can be automated. Which is very interesting. The entire rocket, so filling it up, sending it to space, navigating around, collecting resources, getting back, landing, getting out the resources, refilling, and send it again. All of that can be automated. Which is funny. I wonder if anything new got produced. Yes! Yes, it did! Copper! More iron. And a lot of coal and cobalt. Silicon, that we already know. That iron we also know. That iron is new and that copper is new. I can send you the link to it if you want. The math and the code is on the website. Yeah, I kind of want to make it myself. I'm not one like I could probably also like get a script for that thing, but we made our own script. I mean, it's cool. Like that's part of the game. You have to overcome a challenge, and the challenge here was programming the centrifuge, getting it up and running. I'm with a very stupid program that is not very smart, but it works. It takes some time and could be probably done more efficiently, especially if you would be using this here. But I'm not doing that because I'm stupid. Because I don't have the brain cells to think about something like that, I guess. And same thing could be done with there. And I want to do that over there. Because I can. You know what would have been amazing? If we could have seen the rocket then in orbit and then fly to those moons around, essentially, that exist here. Umbilical gas destroyed. And umbilical power. But okay, first rocket. Let's build the umbilicals again, just to make sure that we have them again, and that they are connected and placed and stuff, so that we can do crazy shit with it. But yeah, that was exciting, guys. That was really, really exciting. And we didn't crash it nor lost the rocket. Copper install. Could have grabbed the copper from outside. No, not the iron. I need the copper. And the steel. And power umbilical. No. The other gold shiny thing. I mean, you don't have to use the script, but the math may be better to have. Yeah, the math definitely is. I mean, you can also send the script into. You can also send the script into the Discord server, as well as the math behind that. As we could at least use, like, we could at least maybe use the script as inspiration for. Yeah, as inspiration essentially on how we could approach it, essentially. Not copying it, but like inspiration. Okay. So that is all connected up now. That is our bare bones rocket. So rocket cargo bay. Okay, there is a cargo bay. That was like one thing that I was thinking about right now. So like, if you can, like, we have to build stuff like that. How do we store ice in the end? I mean, we're probably not gonna be able to put a production facility in there, but like, do we have to put in a stacker, or do we have to put an SDB silo in so that we can properly store it, or do we have to make a jute maze to store the to store that stuff? Stuff like that. But okay, it seems like there is a cargo bay, and that cargo bay has a slot. Rocket payload. Oh, that's the deploy thing, probably. That has nothing to do with the ice stuff and etc. But we can probably put something in there in the payload. I mean, there is no kit. There is no kit that we can so we can build it. There is no kit for it. And it doesn't have a proper name yet, so maybe that's something for the future? And that probably is related to the deploy button. Here, cargo storage. That is the thing that I desired. There we can also see a chute entrance and connect. Is that a connector? Export, import, export. I don't know if that is a chute connection or if that is a cargo umbilical. And that is a rocket miner. There you have to mount drilling heads. Umbilical. Yeah, umbilical socket chute. And then umbilical... Okay, yeah, that is like the thing that goes on the launch tower. Okay. But yeah, umbilical socket chute. So I assume the cargo storage, that is a chute connection and not umbilical socket. But you can put in all of that stuff apparently. We can place it inside. We can build direct heat exchangers. But we cannot put down counterflow heat exchangers, it seems. Huh. But yeah, so like... Okay, so... I guess the deploy button is... nothing for us to use, as that seems to be rather in-depth, I guess. At least it looks like in-depth. And rocket miner is rather obvious now how it goes. We need a cargo storage, a cargo storage so that we can store the ice stuff, and we need a rocket miner to mine the rocks. And on the rock miner, we have to put on the drilling heads. Somewhere. And then we have to connect the drilling heads. And we then also have to connect the cargo storage, medium or small, using chutes to the rocket miner and to the umbilical socket chute. Or umbilical socket angle chute. And that connects to the umbilical chute, and there we can then take out a chute and put it over there as entrance or whatever. I assume as such. I just assume that. Okay, I think that stuff is empty now. Okay, now we are now draining that, so we can do that. Okay. I was worrying about if we can actually pump out stuff from here, but okay, if the connection is there, it's just like a normal pipe connection, it seems. Which is what I would have expected, but it previously looked like it would behave a little bit different, but no, it seems to behave just as expected. As you can see, I'm pumping out that stuff now. Pumping that into the fuel line here. With our amazing turbo pump. So, okay, I'm now just hoping to empty out the entire thing here, the entire rocket, because for the next trip I'm gonna expand the rocket. First of all, a larger tank and miner and storage for the miner, cargo storage. Gonna use the larger cargo storage. That means we need to, and then obviously means we need more fuel because we need to go further. And we have more mass to transport. So that also influences the fuel consumption, like the mass of stuff that we have on board. And yeah. So, and that's why we definitely need a larger fuel tank. So yeah. So that is also another question that needs to be answered. What is the difference between an inline tank, essentially, and a gas like the larger inline tank? Here, inline tank gas and the gas capsule tank, small. What's the difference? I mean, we definitely know this thing here is larger, okay. But what is about that? Oh, wait, I think I know. Okay, well, I mean, the capsule, the capsule one has an integrated, has an integrated pipe analyzer, essentially. Okay, there is that. But is there a capacity difference, or what's going on there? Gas capsule tank, small, volume 250 liters, 60 megapascal. And here, thermal convection, 0114. And then inline, insulated, I'm mostly interested in. Constructible in rockets, true. Max pressure, 60 kilopascals. Volume 250. 250, 60 kilopascal. So, but the insulated one doesn't have any reading on thermal convection and radiation. Ah, okay, so it's completely zero. I didn't expect that to be completely zero. When you have an insulated pipe, I expected stationeers to have at least a little bit of convection and stuff, but that it's completely zero, that is crazy. Okay. But really lovely. Really lovely. Makes working with it a lot easier. Allows to makes the stuff a lot more controlled, I guess. But here, thermal convection 0.025, like 0.025 and 0.001. That is less than this. Like here we have thermal radiation of 0.005 and here 0.001. So, aka the gas capsule tank small has a higher thermal convection and thermal radiation than the uninsulated inline tank gas. Inline gas tank. And it's important, it's a gas capsule tank. It's not a liquid one. So, is really the only difference why you might want to use that the internal pipe analyzer? Is that really the only reason? Or why would you want to use that? I'm confused. Okay, pipe network is empty. Empty. Can turn off that guy now. So yeah, it was. So we're gonna end the stream now, guys. Yeah, it was a lot of fun. I mean, so what? So okay, as always, let's do retrospective. What did we do today? Well, first of all, we automated our coal power plant so that that guy is now IC controlled and is based on the power storage at the bottom, gets turned on and off, essentially. So that works. Yeah, we are still getting new coal, if I see that correctly, which indicates that we are producing more coal than we are using, which is very good, which is very, very good. We have automated... Okay, yeah, using 3, it's filling up. Using 2 seems to be too little. We have also now fully automated the combustion centrifuge, so that one automatically shuts off when it has 1,000 grams of reagents. It will then open up and drain everything out. Once that is done, it closes up again and then starts up the combustion centrifuge again. It smelts all of that stuff down, but that was already the case, so yeah. We also now have a nice little new pipe that goes here all the way around into our base, which allows us to have essentially a full loop here, so to refresh the entire air. So we can scrub the air over here, and the freshly new scrubbed air gets pumped through that pipe to the opposite end of the base, and then the air flows effectively through the tunnel, like through the main base, through the window room and stuff, through the entrance, down the stairwell, through the hallway, and into the atmospherics room. So yeah. We got that.
Hey guys, my name is Chris Luno and welcome to the Plant Cave Living Room Sessions. Here we go.
Yeah. Okay. And then we have Turtle decided that we're gonna do rockets, and that's what we did. So we have a rocket setup. Everything we need to launch rockets is in here now. It was a lot of fun to experiment with that. I made a backup to make sure that if the invested resources are not wasted by breaking everything. I mean, we did break those 2 things, which I think is like 60 grams of steel then. But no, wait, gold and copper. It was, I think. Yeah, whatever. That stuff. But okay, at least not the entire rocket, which was a lot more expensive. And the other stuff. But yeah, we managed to do that. We managed to do various things. We can check that out on the computer. So we have discovered Ganymede, prograde moon transfer, whatever that is. We've also discovered Io. Then we have discovered tidal fragments of Io, and we have discovered Io condensate, and then we have discovered there 4 resource sites, 3 pollute sites, and 1 volatile condensate site. but stupidly enough, we didn't fly to the volatile condensate site because I cannot read. But yeah, it was a lot of fun. So the question is now, so like that was the retrospective of what we did today. I'm very happy as we now have quite a bunch of resources here, and that gets constantly produced, fully automated. No, not fully, like, but the not automated stuff is pushed quite far away, because what does this system here need from me as a stationeer? It only requires, like, okay, it requires the atmospherics to run and like have power and whatnot, but like the main thing is that like if everything, like there is like the dependency hell is like really deep, and there is stuff that that practically are infinite but theoretically not, or require low maintenance. I mean, there's always a little bit of maintenance essentially, and the atmospherics lab down there has currently human maintenance in regards of filters, but those can be produced using the resources that we get from the deep ore miner. So resource wise, that is infinite. The only thing that is there are a few more things that are concerning, like volatile ice, like volatile gas itself is not automated. We need to collect that manually, and volatile gas ice produces not just like volatile gas but also a little bit of other stuff, and that has to go through filters and stuff, and maybe end in a tank that we are not, where we don't have a overpressure regulator, aka the tank could explode. That's again also a maintenance thing then, like making sure that the tanks don't have too much stuff in them. That's another thing for us to worry about as a stationeer. But generally speaking, the rest, except also like creating the filters essentially, that is automated. And another thing that is maybe problematic is that the vending machine can run full, and then the chutes run full, then the stackers run full, then the other chutes, and then the arc furnace is in those chutes, and then we are effectively not producing resources anymore. And that is most significantly in regards of coal, as we currently produce apparently a lot of coal that end up in the vending machine unused, which means that that we use a lot of slots for coal, and at some point, if we don't use that coal and adjust the other ingots, that would mean that we may back up the entire system with just coal in the end, and don't get any access to the other resources. That's also a small problem that can happen. Holy shit! I never saw hydration. Current hygiene decreasing, suit or helmet on. Damn it. Okay. I never got a hygiene warning, but we have a hygiene warning. Okay. I need to take a shower, apparently. Well, or having the EVA suit off for some time. Let's go inside then. And put off the EVA suit. Okay, so the question is, what do we do next time, guys? That's the main. That's like the next main question. As said, gonna end the stream now. The question is, what are we gonna do next time? I think like what I would say, we're gonna continue to work on the rocket, and as said, expand the fuel storage and add mining capabilities to the rocket. I also would like to build a telescope and check out what that does essentially. and all the necessary stuff for the telescope, because I think we need a computer and circuit board for that, probably a motherboard for that, probably, and a celestial tracker for the rocket as well. That's the stuff I want to try out, and probably also increasing the, instead of an auxiliary battery, using a medium battery, because the miner probably uses a lot of power, so that would be good as well. Yeah. I don't know if there are ways for us to produce power in space. I mean, there are theoretically solar panels, but I don't know if we can place them inside of rockets, and I guess inside rockets doesn't make sense. But there we probably cannot deploy solar panels, so there is that a little bit in regard of worrying. And I don't think that we can, like, take the ice that it collects, create fuel out of it, and burn that fuel, and then use that as power source. I think it really relies on what we charge it with on ground. I don't think that we're gonna automate the rocket next time, though. I think that will take quite some time till we automate that. But what we might do is automate the resource processing of the rockets. Like now, like when we next time add mining capabilities, then we also should make sure that the tubes and stuff are working. For that, we gonna connect it up to our existing filter system, and then we gonna add on top of it a new sorter that sorts out the ice, and then we gonna deliver the ice over to our atmospherics, or we just put it directly into an ice crusher, and the ice crusher then goes into the waste pipe, because the waste pipe goes to the filtration stuff. We need a control unit there to make sure that it doesn't overpressurize, of course, and it needs to drain the liquids that's produced in there. But generally speaking, that's, I think, what we're gonna do as well next time. And I don't know if there's more time for anything else, but think about what we should do after semi-automating the rocket. Very important, semi. I'm not gonna automate the rocket journey itself. We're gonna keep that one manually driven. Though maybe we're gonna make an alarm system. That I think is doable. So that, like, saying we get an alarm or whatever if we are too close or whatever. Yeah. There's one interesting thing I would want to check out, and that is like a hard suit. A hard suit has a programmer chip slot. Is it able to... Okay, there is like sound alert, which is really cool. That's interesting for us, essentially. Orientation, forward, reference, entity state, ratio. But like, can it consume? Is there like a way to communicate? There's logic slots, occupied, pressure, glass, max quantity, stuff like that. And there is internal memory. Okay, wait. Size is 0 byte, but there is internal memory. Okay. Okay, so there's like, yeah, I mean, definitely like having the rocket there, and then also I think I will add an IC or whatever to the ground system, not the rocket itself, because that would require power, that allows us to check, like to sound an alarm when the battery runs low, so that we can then say, yo, rocket, come back home, essentially. We then have to do that manually, getting the rocket back home, essentially, but a sound alarm for that would be really cool, and using like the wireless logic stuff would be interesting, so maybe looking into that as well. So again, my plan is a little bit of rocketry and a little bit of programming next time, and I probably don't think that we can achieve anything else than that. But yeah, Turtle, feel free to think about what we could do other than that. So now I'm gonna by the way, I'm probably gonna read a little bit upon the hard suit here, if we can do some radio communication stuff there. That would be really cool. radio communication would be really cool if we could do with the hard suit, and then get an alarm essentially. That would be cool. Reading up on that, and maybe some other rocket related stuff. We will see, like the telescope thing. But yeah, we will see. Let's save. Save as Europa. I didn't. Oh my goodness! It overwrote pre-launch. I said save it as Europa and not pre-launch. God damn it. Okay, so that means the backup was not a backup. That's the thing. Hello? Oh. Okay. I thought like clicking on that allows me to save it as that, but no. Okay, that's on me then. But okay, we didn't have a backup. We risked it all, or at least I risked it all. Whatever. Europa. So then, guys, then I would say you did have a backup just with a different name. Yeah. Oh, right. Wait. So Europa was then the backup. Okay, I get it. Yeah. Anyway, next stream. I don't know when that will when that one will be. I don't know if it will be tomorrow or on Monday or on Tuesday. I don't know. We will see. I rather suspect Monday. Like Monday is quite possible because Monday is a day where I have I have like a lecture to 18:45. Then I drive half an hour home. And there's like, I'm not gonna do anything else. I'm not gonna do uni stuff and whatnot. So highly likely that on Monday there will be Monday evening there will be a stream. Highly likely, but not as long as the last few streams. Probably only till 12 p.m. or half 12 because I have to get up early on the next day. So yeah. But okay, guys. I'm gonna try to find a little bit of stuff, read upon a little bit of stuff like Rove and shit, and especially like I always see the rocket where stationery can go inside. I want to check out that. What is wrong? What is up with that? But anyway, thank you guys so much for watching. I was Peter O. I say bye. Until next time, and as always, keep coding. No, that was the wrong screen.